Hello, and welcome to the WorldWarlab channel. Today's story takes us to a cold RAF airfield in 1941, where a quiet engineering problem was killing pilots faster than enemy bullets. At 7:42 on the morning of March 14, 1941, Beatrice Shilling stood on the tarmac at RAF Kenley, watching a Hurricane pilot climb into his cockpit for what might be his final sortie. She was 32 years old, had spent 6 years at the Royal Aircraft Establishment, and so far had found zero official solutions to the problem that was getting her pilots killed. That week alone, the Luftwaffe had sent 43 Messerschmitt Bf-109 fighters across the channel. RAF pilots had intercepted them in 27 separate dogfights. 14 Hurricanes had been lost. 9 Spitfires as well. The pattern never changed. A British pilot spotted a German fighter. He pushed his aircraft into a dive to attack. The engine cut out. The German fighter escaped, or worse, looped back around and riddled the stalled Hurricane with bullets while the British pilot fought desperately to restart his Rolls-Royce Merlin engine. Shilling had studied the combat reports. She had gone through the maintenance logs line by line. She had interviewed the pilots who survived the engine failures. The cause was always the same. During -G maneuvers, the carburetor flooded. Simple physics, brutal consequences. When a Spitfire or Hurricane snapped into a sudden dive, fuel surged to the top of the float chamber. The jet starved. The engine died for roughly 1.5 seconds. 1.5 seconds was enough time for a Messerschmitt to close 300 yards and open fire. The Germans didn't suffer from this flaw. Their Daimler-Benz engines used direct fuel injection. No float chamber. No flooding. Bf-109 pilots could dive, climb, roll, or fly inverted without losing power for even a heartbeat. It gave them a decisive edge in every engagement. British pilots knew it. German pilots exploited it. Squadron commanders reported it again and again. And the Royal Air Force was losing experienced pilots faster than the training schools could replace them. Shilling had spent 11 months attacking the problem from every angle. Engineering teams at Rolls-Royce were working on a pressure carburetor, a proper fix, a complete redesign of the fuel delivery system. But it wouldn't be ready until 1943, maybe even 1944. The war wouldn't wait. The pilots couldn't wait. Every morning, young men climbed into Spitfires and Hurricanes knowing their own engines might kill them before the Germans ever got the chance. Squadron leader Davies walked past Shilling toward his Hurricane. He was 24 years old, had flown 41 combat missions, and claimed 3 confirmed kills. He had reported engine failure twice in the previous month, both times during combat dives. Both times he survived through a combination of luck and 3,000 hours of training. He nodded to Shilling as he passed. She nodded back. He had no idea she was the carburetor specialist from Farnborough. He probably assumed she was someone's secretary. If you want to see how Shilling's breakthrough saved RAF pilots, please hit that like button. It helps us share more forgotten stories from the war. And if you haven't already, subscribe. Now, back to Shilling. She hadn't come to Kenley empty-handed that morning. In her possession was a small brass component, precisely machined and almost absurdly simple. Her team at the Royal Aircraft Establishment had tested it on a bench engine for 6 weeks. It worked. But bench tests weren't combat. Combat meant 300 miles per hour. Combat meant -G forces strong enough to pin a pilot into his harness. Combat meant life or death decided in 1.5 seconds. Shilling walked toward her Norton motorcycle. Inside her leather satchel sat the brass restrictor, along with a plan that would either save the Royal Air Force or end her career at Farnborough. By noon, she would know which. The carburetor problem had first appeared in July of 1940, when the RAF switched to 100-octane fuel. Higher octane allowed more boost. More boost meant the Merlin engine could produce 1,310 horsepower instead of 1,100. The Spitfire Mark II could reach 370 miles per hour in level flight, fast enough to catch Bf-109s. But the Skinner's Union carburetor couldn't cope with the -G forces that came with high-speed combat maneuvering. Shilling understood carburetors better than anyone at Farnborough. She joined the Royal Aircraft Establishment in November 1939, just 1 month after war was declared. She was one of only 2 women in the engine department. The other was a secretary. Shilling was the principal technical officer responsible for carburetor research and development. Most of the men she worked with had never encountered a female engineer before. Some of them didn't believe women belonged in engineering at all. Shilling didn't care what they believed. She cared about keeping pilots alive. She had grown up taking engines apart. At 14, she bought her first motorcycle, a Norton, and stripped its 2-stroke engine down to individual components, learning exactly how each part worked before rebuilding it from scratch. At 25, she raced that same Norton at Brooklands, averaging 106 miles per hour, fast enough to earn the British Motorcycle Racing Club's Gold Star. Only 3 women in history had ever earned that award. Shilling was the second. Racing taught her how engines failed under stress. High G-turns, sudden acceleration, extreme lean angles. She learned to feel what an engine needed before the gauges ever showed a problem. That intuition made her the finest carburetor specialist in Britain. And now British pilots were dying because their carburetors couldn't survive the stresses of combat. The solution came to her in January. Again, it was simple physics. The float chamber flooded because fuel could flow freely when gravity reversed. So what if the flow was restricted, not stopped entirely, just limited enough to prevent flooding? The engine would still receive fuel, just not too much. The answer was a brass disc with a precisely calculated hole drilled through its center. Installed in the fuel line ahead of the carburetor, it would limit maximum fuel flow to slightly less than what the engine demanded at full throttle. Shilling machined the first restrictor herself. It was shaped like a brass thimble, 1/8 of an inch in diameter. The hole in the center measured 0.040 inches. Those measurements were critical. Too large and the carburetor would still flood. Too small and the engine would starve at full power. She tested 17 different sizes before finding the perfect balance. After that, she simplified the design. A flat washer would be easier to manufacture, easier to install, and easier to replace if damaged. Bench tests had already proven the concept. The restrictor stopped the carburetor from flooding during simulated negative G conditions. But bench tests were not combat. To truly prove it worked, Shilling needed the device tested on a real aircraft, flown by a real pilot under real combat stress. The real obstacle was permission. Installing an unauthorized modification on an RAF fighter violated roughly 40 different regulations. If the restrictor failed during combat and a pilot was killed, Shilling could face a court-martial, possibly even prison. After weighing the risks, she made her decision. She would skip permission and ask for forgiveness later. That morning at Kenley, she had 6 restrictors in her satchel, and one extremely cooperative ground crew sergeant who owed her a favor. Sergeant William Cooper had been working on Merlin engines for 3 years. He had personally seen 19 pilots die from engine failures. When Shilling showed him the small brass washer, he didn't ask a single question. He simply nodded and reached for his tools. The Hurricane sat on the dispersal pad. The pilot was already inside. The engine was warming up. There were 20 minutes until takeoff. Cooper moved quickly. He disconnected the fuel line between the pump and the carburetor. The restrictor slid neatly into place. He sealed it using a small butane torch. The entire job took 60 seconds. Once finished, the modification was invisible unless you knew exactly where to look. Shilling inspected the weld. It was clean, solid, and professionally done. Squadron leader Davies would be flying with the restrictor installed. He had no idea it was there. Shilling hadn't told him. She hadn't told the squadron commander. She hadn't told anyone except Cooper. If the restrictor failed and Davies was killed, there would be no paperwork, no authorization, no test records, only a dead pilot and a brass washer that was never supposed to be in the aircraft. The Hurricane's Merlin engine roared to full power. Davies ran through his pre-flight checks. Oil pressure normal. Coolant temperature steady. Magnetos firing cleanly across all 12 cylinders. He released the brakes. The Hurricane rolled forward, picked up speed, and lifted off the runway. Shilling watched it climb. 800 feet. 1,200. 2,000. The aircraft banked south toward the channel. She raised a pair of binoculars and followed the climb as Davies reached 15,000 feet. 2 more Hurricanes joined him, forming a standard 3-aircraft patrol section. Together, they headed toward Dungeness. German fighters had been active over Dungeness all week. If Davies encountered a Messerschmitt, he would have to dive, and the restrictor would either work or it wouldn't. Shilling waited on the tarmac. Cooper stood beside her. Neither spoke. Around them, the station carried on as usual. Ground crews prepared 2 more Hurricanes for the afternoon patrol. A fuel truck rumbled past. Mechanics shouted technical jargon across the dispersal area. The normal sounds of a fighter base at war filled the air. Shilling heard none of it. Inside her head, she was running calculations. A 0.04-inch aperture. Maximum fuel flow at full throttle. 1.5 seconds of negative G. On paper, the math worked. But paper wasn't combat. 40 minutes passed. Then an hour. There was no radio traffic from Davies' section. That silence could mean anything. No contact with enemy aircraft, or contact so intense there was no time to report, or that Davies was dead and his Hurricane was scattered across a French field. At 9:37 a.m., the radio crackled to life. The controller's voice cut through the static. 3 Hurricanes inbound. 2 minutes out. Shilling snapped the binoculars up. She saw them immediately, 3 dark silhouettes against the pale morning sky. All 3 aircraft. No losses. The Hurricanes entered the circuit. Davies landed first. He taxied to dispersal, shut down the engine, and climbed out of the cockpit. Shilling walked toward him. Her hands were shaking. She had designed bombs before. She had tested engine modifications in laboratories. She had never done anything like this. Never sent a pilot into combat with an unauthorized modification she personally installed. Davies pulled off his helmet. He was smiling. That alone was strange. Pilots rarely smiled after combat patrols. They usually looked drained, hollow, haunted. Davies looked energized. Cooper asked the question. "Any problems with the engine, sir?" Davies looked at Cooper, then at Shilling, then back at Cooper. "Best the Merlins ever run," he said. "Dived on 2 Messers over Dungeness. Engine never missed a beat." Shilling asked him to describe everything in detail. Davies explained that he had spotted 2 Bf-109s at 14,000 feet, both heading east toward France. He maneuvered his section above them, gaining the altitude advantage. Then he pushed his Hurricane into a steep dive, 400 miles per hour. The negative G-forces were strong enough to lift him against his harness straps. It was exactly the kind of dive that should have killed his engine. But the Merlin kept running. Full power throughout the entire descent. Davies closed to 200 yards before the German pilot even realized he was under attack. He fired a 3-second burst and saw strikes tear into the left Messerschmitt's wing root. The German fighter broke hard to the right and fled toward France. Davies pulled up and climbed back to altitude. The engine performed flawlessly the entire time. It was the first successful diving attack he had completed in 11 months without experiencing an engine cutout. Davies wanted to know what maintenance had done to his Hurricane. Shilling told him everything. She explained the restrictor, the brass washer, the fuel flow limitation. Davies stared at her for 5 seconds. Then he turned to Cooper. "Put that thing in every Hurricane on this station," he said. "Today." Shilling reminded him the modification wasn't authorized. Davies didn't care about authorization. He cared about staying alive. Every pilot at Kenley had lost friends to engine failures. 19 pilots dead in 6 months. Davies said if the brass wanted to court-martial him for installing an unauthorized modification, they could do it after the war. Right now, his squadron needed engines that worked. That afternoon, Cooper installed restrictors in 4 more Hurricanes. Shilling had brought 6. She kept one aside for further testing. Over the next 3 days, 5 Hurricanes flew combat patrols equipped with the restrictor. There were 0 engine failures. 12 diving attacks were successfully pressed against German fighters. Pilots reported that the Merlin engines ran perfectly, better than they ever had before. Perfectly. Some pilots even claimed they were getting slightly more power at altitude. The news spread fast. By March 18th, every squadron commander in number 11 group knew about the restrictor, and they all wanted it, immediately. Shilling received 14 phone calls in just 2 days. Could she come to their stations? Could she bring more restrictors? How quickly could they be produced? The problem was supply. Shilling had machined the original 6 restrictors herself in the RAE workshop. Producing thousands would require proper manufacturing facilities, reliable brass stock, precision machining, and strict quality control. She needed approval from the Air Ministry. She needed funding. She needed time. She got approval in 4 days. The Air Ministry fast-tracked her proposal, calling it a potentially war-winning modification. Rolls-Royce received the production contract. They could manufacture 500 restrictors per week. Installation would begin immediately at every fighter station in Britain. Shilling assembled a small field team, 3 engineers from Farnborough and 2 civilian mechanics. Their mission was to tour RAF stations and oversee installations. The restrictor could be fitted without removing aircraft from service, which was critical. Every Hurricane and Spitfire needed to remain operational. The Battle of Britain was technically over, but German fighters still crossed the Channel daily. Fighter Command could not afford to ground squadrons. Shilling loaded her Norton motorcycle with tools and restrictors. She had visited 43 RAF stations before the war. She knew the fighter bases of southern England, the commanding officers, and the ground crews. Now she would visit them again, carrying a small brass washer that could save their pilots' lives. By March 25th, installation teams were ready. 600 restrictors had been manufactured. 40 stations were on the schedule. Nearly 3,000 Merlin engines were waiting to be modified. Shilling started her Norton and headed north toward Biggin Hill. Biggin Hill was the busiest fighter station in number 11 group, home to 32 Spitfires, 21 Hurricanes, and 4 squadrons rotating through continuous combat operations. She arrived at 8 a.m. on March 26th. The station commander, Group Captain Grice, met her at the gate. He had lost 7 pilots to engine failures in the previous 2 months and wanted the restrictors installed immediately. Ground crews worked in shifts, modifying 4 aircraft at a time. Each installation took 12 minutes. Disconnect the fuel line. Weld the restrictor in place. Reconnect the line. Test for leaks. The welding had to be flawless. A poor weld at altitude could starve the engine completely. Shilling personally supervised every installation. She inspected every weld, tested every connection, and rejected 3 restrictors that failed to meet her specifications. Pilots watched the process closely. Flight Lieutenant James Lacey had flown 41 combat missions and experienced engine failure twice, both during critical moments in dogfights. He asked Shilling how something as simple as a washer could solve such a complex carburetor problem. She explained fuel flow physics, float chamber behavior, and the effects of negative G-forces on liquid fuel. Lacey understood immediately. He was an engineering graduate from Cambridge. He called it brilliant simplicity. By March 28th, all 53 Merlin engines at Biggin Hill had restrictors installed. Shilling moved on to Hornchurch, then North Weald, then Tangmere. The same pattern repeated at every station. Ground crews worked 12-hour shifts. Pilots flew combat patrols with modified engines. 0 failures were reported. The restrictor worked exactly as designed. Pilots began calling it Miss Shilling's Orifice. The nickname came from Sir Stanley Hooker, chief engineer of the Rolls-Royce Supercharger division. It was crude British humor and slightly inappropriate. Shilling didn't mind. She had spent 6 years working with RAF personnel and understood how military men coped with stress. If a crude nickname helped them remember the modification, she was fine with it. The name spread faster than the restrictor itself. By April, every pilot in Fighter Command knew about Miss Shilling's Orifice and requested it specifically. Some pilots refused to fly combat missions until their aircraft had been modified. Squadron commanders supported them. They had seen too many good pilots die from preventable engine failures. German intelligence noticed the shift in British fighter performance. Luftwaffe after-action reports from early April mentioned improved RAF diving attacks. British fighters no longer broke off pursuit during -G maneuvers. Messerschmitt pilots could no longer exploit the carburetor weakness. Their tactical advantage had vanished. By mid-April, Shilling's team had installed restrictors in 2,100 Merlin engines, every Hurricane and Spitfire in fighter command, every operational training unit aircraft, and every machine held in reserve. The modification became standard equipment. New aircraft rolling off production lines at Castle Bromwich and Southampton were delivered with restrictors already installed. The pressure carburetor was still under development. Rolls-Royce estimated it would be ready for production in 1943, but the restrictor worked so well that some engineers questioned whether the pressure carburetor was even necessary. Why redesign the entire fuel system when a 50-cent brass washer solved the problem? Shilling knew the answer. The restrictor was a stopgap, an elegant, effective, temporary solution. The pressure carburetor would eliminate the -G problem entirely. No flow restrictions. No power limitations. Full engine performance under any flight condition. That was the correct engineering solution. But until 1943, Miss Shilling's orifice kept RAF pilots alive, and that was enough. The results were measurable. Fighter command tracked combat statistics meticulously. Every engagement, every kill, every loss told a clear story. In March 1941, before the restrictor, RAF fighters reported engine failures in 38% of diving attacks against German aircraft. Pilots were forced to break off pursuit. Enemy fighters escaped. Or worse, German pilots deliberately exploited the weakness, luring British fighters into dives knowing the Merlin engines would fail. In April 1941, after the restrictor's introduction, engine failures during diving attacks dropped to 0.4%, almost non-existent. The few failures that did occur were unrelated to the carburetor, caused instead by mechanical damage or battle. Damage, normal combat attrition. The kill-to-loss ratio improved immediately. March had been brutal. Fighter command lost 47 Hurricanes and Spitfires in combat while shooting down 61 German aircraft, a ratio of roughly 1.3 to 1, barely breaking even. April told a different story. 29 British fighters were lost. 94 German aircraft were destroyed. The ratio jumped to 3.2 to 1. The restrictor wasn't the only factor, but squadron commanders consistently credited it as a major contributor. Pilots reported a new confidence in combat. Flight Lieutenant Robert Stanford Tuck flew Spitfires out of Duxford. Before the restrictor, he had experienced engine failure 4 times. After installation, he pressed diving attacks without hesitation. He destroyed 3 Messerschmitt 109s in May and 2 more in June. He openly credited the restrictor with giving him the confidence to commit fully to aggressive tactics. The modification quickly spread beyond fighter command. RAF Coastal Command requested restrictors for their bow fighters. Bomber Command wanted them installed on training aircraft. Even the Fleet Air Arm asked about fitting them to carrier-based fighters. Shilling coordinated production with Rolls-Royce. By June, they were manufacturing 1,000 restrictors per week. The restrictor remained in service through 1943. Rolls-Royce finally introduced the pressure carburetor in January of that year. The new system eliminated the -G problem entirely, using fuel injection principles similar to those in German engines. No float chamber. No flooding. Perfect fuel delivery under any flight condition. But converting existing aircraft required extensive work, removing the old carburetor, installing new fuel pumps, rewiring engine controls. Each conversion took 8 hours, and during those 8 hours the aircraft couldn't fly combat missions. Fighter command couldn't afford to ground squadrons for prolonged maintenance, so many units kept the restrictors. Numerous aircraft flew with Miss Shilling's orifice until 1944, and some carried it until the end of the war. New production Spitfires and Hurricanes received pressure carburetors, But older aircraft kept their restrictors. Pilots trusted them. Ground crews knew how to maintain them. If it worked, there was no reason to change it. Shilling moved on to other projects. She worked on cold-weather engine starting systems for aircraft deployed to Iceland and the Soviet Union. She investigated high-altitude fuel mixture problems and helped design improved supercharger systems for late-war Merlin variants. The Royal Aircraft Establishment kept her occupied with a steady stream of critical technical challenges, but the restrictor remained her most famous contribution. Pilots remembered it. Engineers studied it. After the war, aviation schools taught it as an example of elegant problem-solving under pressure. A simple solution, rapid implementation, and measurable results, everything good engineering should be. Years later, Keith Maddock, chief engineer at Hangar 42 during the war, summed it up plainly. Beatrice Shilling helped win World War II. Of that, there was no doubt. The restrictor was a war-winning modification. Shilling's work did not end with the restrictor. The Royal Aircraft Establishment faced dozens of life-threatening problems that demanded immediate solutions. Engine failures at high altitude. Fuel system icing in extreme cold. Starting issues in Arctic conditions. Every problem put pilots at risk, and every one landed on Shilling's desk. She developed cold-weather modifications for Spitfires deployed to Murmansk. Russian winter temperatures dropped to -40 degrees Fahrenheit. Standard engine oil turned to sludge. Batteries failed. Fuel lines froze solid. British pilots couldn't start their aircraft, and Soviet ground crews had little experience with Merlin engines. Shilling devised a cold start procedure using preheated oil and adjusted fuel mixtures. It worked. Spitfires flew combat missions over Murmansk throughout the winter of 1941. She also tackled high-altitude performance issues. Late-war Spitfire variants operated at 35,000 feet, where the Merlin engine struggled. Thin air and low oxygen content meant fuel mixtures had to be calibrated with extreme precision. Too rich, and the engine flooded. Too lean, and it overheated. Shilling developed altitude-compensating carburetor modifications that increased power output by 8% above 30,000 feet. Her personal life remained largely separate from her work. She had married George Naylor in September 1938. He worked at the Royal Aircraft Establishment as an aerodynamicist. When the war began, he volunteered for RAF Bomber Command and flew Avro Lancasters with 625 Squadron, completing 31 combat missions over Germany. He earned the Distinguished Flying Cross for flying an additional tour beyond his required missions. Shilling worried every time he flew. She understood bomber loss rates. Bomber Command suffered higher casualties than any other RAF branch. 1 in 2 bomber crew members did not survive the war. Naylor beat those odds. He completed his tours and returned to Farnborough in 1944. They rarely spoke about his missions. He didn't ask about her projects. They kept work and marriage in separate compartments. Shilling continued riding motorcycles whenever time allowed. She had stopped racing at Brooklands when the war began. The famous circuit had been converted into aircraft production facilities, but she never gave up her Norton. Fast riding helped her think. Some problems that resisted laboratory analysis unraveled while she was riding country roads at 90 miles per hour. By 1945, she had worked on 17 major projects at Farnborough: cold weather systems, high-altitude modifications, carburetor improvements, fuel mixture optimization, supercharger efficiency upgrades. Each project saved lives. Each kept RAF aircraft operational under extreme conditions. None, however, matched the fame of the restrictor. The war ended in May 1945. Germany surrendered. Japan followed in August. The Royal Aircraft Establishment shifted from wartime emergency projects to peacetime research, slower, less urgent, driven by different priorities. Shilling stayed at Farnborough. She had no intention of leaving. Engineering was her life. In 1948, she received official recognition for her wartime contributions. King George VI appointed her an Officer of the Order of the British Empire. The OBE ceremony took place at Buckingham Palace. Shilling wore formal dress, accepted the medal, posed for photographs, and then returned to work at Farnborough the very next morning. She never stopped engineering, never stopped solving problems, and never stopped proving, quietly and relentlessly, that women belonged in technical fields. Her career at the Royal Aircraft Establishment continued for another 21 years, but the restrictor remained her defining legacy, the small brass washer that helped save the Royal Air Force. Shilling worked at the Royal Aircraft Establishment until 1969, completing 33 years of uninterrupted service. She never rose to the highest administrative positions. Those posts were reserved for men. The RAF leadership structure simply did not promote women to director-level roles, regardless of achievement. Shilling accepted that reality without bitterness. She preferred hands-on engineering anyway. Laboratory testing, field modifications, real problems demanding real solutions. Her post-war work was wide-ranging. She contributed to the Blue Streak missile program, Britain's first ballistic missile, focusing on fuel delivery systems and high-altitude performance. She investigated wet runway braking effects for jet aircraft at a time when landing accidents were killing more pilots than engine failures. Understanding how standing water affected tire friction could save lives, and Shilling published 3 technical papers on the subject. She even helped design a bobsled for the Royal Air Force Olympic team. It seemed like an unusual project for an aeronautical engineer, but bobsled design depended on aerodynamics, weight distribution, and friction management, disciplines Shilling had mastered over 3 decades. The RAF team used her design in competition. They didn't win medals, but they didn't crash either. Shilling retired in 1969 at the age of 60. Retirement didn't slow her down. She spent her time restoring vintage motorcycles, occasionally racing at classic motorcycle events, and maintaining her beloved Norton. She had owned the same motorcycle since 1934, the machine she raced at Brooklands, the machine that taught her how engines behaved under extreme stress. She died on November 18, 1990, at the age of 81, survived by her husband George and a lifetime of engineering achievements. British newspaper obituaries focused almost entirely on the restrictor, the brass washer, Miss Shilling's orifice. Everything else she accomplished became a footnote. Her legacy endured in unexpected ways. In 2011, a pub in Farnborough was renamed the Tilly Shilling. In 2015, the Brooklands Museum acquired her racing trophies and badges. Winchester Heritage honored her in 2018 as one of Hampshire's extraordinary women. In 2019, Royal Holloway University opened the Beatrice Shilling Building for electronic engineering students. That same year, on March 8, the mayor of Waterville unveiled a commemorative plaque at the local library, 110 years after her birth. The restrictor itself became a teaching tool. Engineering schools around the world studied it, a simple solution to a complex problem implemented immediately under wartime pressure, with measurable, life-saving results. Everything good engineering is meant to achieve. Some universities even kept original restrictors on display, small brass washers sitting in glass cases, reminders that elegant solutions do not require complexity. If this story moved you the way it moved us, do us a favor and hit that like button. Every single like tells YouTube to share this story with more people. Subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every day. Stories about engineers who saved lives with brass washers and brilliant thinking. Real people. Real heroism. Drop a comment and tell us where you're watching from. Texas, Germany, the United States, Japan. Our community spans the entire world. You're not just a viewer. You're part of keeping these memories alive. Let us know you're here. Thank you for watching, and thank you for making sure Beatrice Shilling doesn't disappear into silence. She deserves to be remembered, and you're helping make that happen.